Hello everyone, welcome to another build from Ampro Engineering. What we have here is a body that we had talked about many episodes ago, which was by Plastic Dreams. It is a original Fiat Panda, and I'm sorry that it doesn't fit in the screen, but this body is gigantic, which is ironic given how small the actual car is. The reason it's so big is it was designed and intended to be placed on my least favorite chassis in history, the Tamiya CC01. Now, I don't want to dive into why I don't like this chassis, but it has little to do with the chassis and more to do that it is 2019 as of the filming of this video, and this is still what Tamiya considers a trail truck. Nevertheless, everybody tells me this chassis is fantastic, so we are going to proceed building this Panda on this chassis. We're not going to look at this too much right now because we have to do some prep to the body, but I did mock up a wheel designed for this car. Now, these are the tires you're going to get. These are 7825 R 15.5 wheels from RC 4-wheel drive, and they're one of the smallest tires they make for a 1.55-inch wheel, which works because the Panda has very small wheel arches. So you can see that it's roughly going to go in here. The goal for this project is to have it so that the wheels do not protrude, because even with this small of a tire, if it sticks out at all, it's going to catch the wheel arch. And this is going to be a trail car, not a crawler or anything, so I really don't care about that. But I do want to make sure that the wheel fits. And the reason I've done this is to make sure that there's no interference. And as we can see already, the 1.55 is a little bit too small for this hub. But is that a problem? This Panda body is quite wide. So what we need to do is just place it on top, and let's take off this bumper first. So the goal is to see how wide we can have the offset on this vehicle. And it looks like, just eyeballing where the center of the car is, that we have around 5 millimeters of spacing on this side. That's great. This means I don't have to do anything extravagant with the hub. I put the chassis away for now, and what we have to focus on is how to set the body onto the chassis, but also determine what the wheelbase of the vehicle is. Using a metal scale, I've determined that the center to center point on these wheel arches is 256 millimeters. It was easy to do because there's a little divot right there that you can see on both the front and the rear. This is greater than the length of the CC01 chassis I have, so stretching the rear forelink is going to be necessary, but it is not by much, so that's a plus. Next, I'm going to score the body where the wheel arches are, and the rocker panels and the underside of the back and the front, where there's a very faint, you can see it right there, there's a trim line right there, and score that and cut the bottom part of the body off. The body has been cut out, and I've probably gone a little bit conservative on these cuts because I don't know how it's going to look when it's all installed. Here is the separate rear bumper, which gives a little more depth. I guess the beauty of molding a shape like this means that the mold can be pretty simple because the car's actual shape is simple. But for these undercuts on the back bumper, having a separate piece is really nice. I'm going to get the front bumper that will go on like this. We also have headlight buckets, which is fantastic. Headlights, turn signals, the little bit of a grill insert, and we have the rear taillight markers as well. So that'll be fantastic. For once, I don't have to make all my own. The next thing we have to do is get the tires on the chassis to determine our overall wheelbase so that we can stretch the forelink. So I've drawn up some wheels that I'd like to see on this car. Now, these are steel wheels on the real car, and yes, they're silver, but as you can see here, we've gone ahead and printed these out and painted them white just because I kind of prefer it. Now, the rear of the car is kind of floating in space, and before I talk about that too much, what I wanted to mention as well is that the Panda's front and rear track is slightly different. I think the rear is 4 millimeters wider than the front. So what I did is the front and the rear rims are different offsets. So the back sticks out slightly more than the front does, but it does fill the wheel well appropriately. Unfortunately, the wheel base is incorrect, so we're going to have to address that. These CC01 cars are designed to have a variable wheelbase. Unfortunately, the wheelbase that I want is roughly in the middle of these two. It's, I believe, 256 millimeters. So we are going to draw up a little spacer here and print it out right here. So there's some little basic adapters, and we are going to simply install them like that on both the front and the rear mounts, and I think this will be simple and easy. I'm sure there's better ways to do this, but I'm not feeling like going nuts on this here. And of course, we're also going to have to unmount the shock mount from this location here and set it in its furthermost mounting location. I'm slowly disassembling the rear end because I'm going to install a better 4-link set. It's not that the plastic ones are bad, it's just that these are absolutely hideous So that's, to be honest, it's purely vanity that I'm replacing these parts because of. I did also have to look at the drive shaft. This drive shaft is a little bit too short, and now we've got a 125 millimeter drive shaft. This is from the end of the yoke to the end of the yoke, and we'll have to go and take a look and get one of proper length from RC 4-wheel drive. I know that you can get a Tamiya one that's probably close to the right length, but I simply don't want that. I want to have a really solid drive shaft in this. I went ahead and reassembled the rear suspension on the car, and I used this 4-link set from Hot Racing, and I have to admit that the aluminum links themselves are very, very nice looking. The captured ball ends are a FRP, a fiber reinforced plastic. What I do have to mention about these is the actual ball inside the ball end was pressed in there so tightly that when I assembled the rear suspension, if you compressed the springs on it, they would just stay down. What I had to do is actually open up all of these openings with a burr tool on the Dremel in order to get these free. In my opinion, that is simply not acceptable, so I cannot recommend these. I don't know if anybody else has had better luck, but these were quite subpar, as I shouldn't have to do that. The drive shaft is a June Fock carbon steel unit. It is bordering on too long. You can see a little bit of play in here, but oh well. I ordered it, it's installed, it's done. I think the overall stretching worked out pretty well. Okay, over here we're showing the installation of the axles, where you put the C-clips on the axle, then drop it into the enclosure. I had to put shims right here in front of this bearing and right there in front of that bearing to prevent the main differential gear from wandering side to side and losing contact with the propeller joint that Tamiya here called there. I actually heard it called a propeller joint. What was happening with this car is that under load, it would grind at the rear end. And although the gears are in excellent shape, there was just so much axial play that whenever the thing was loaded up too much, you would just hear the gears slipping, and that was not good. So that's been sorted out. The front was in pretty good shape, and to be fair, this truck was beat up when I got it. I paid around $90 for this truck in quote-unquote ready-to-run condition, and it simply was not. The truck was in really bad shape. You can see that the chassis has been cut right here. I've got to make a little brace or something, but for the time being, it doesn't seem to adversely affect the car. What I did have to do to get the interior to fit properly is chop off the top of the motor holder here, because the floorboard was so close that this was actually causing interference. To further irritate the steering system on the CC01, I've made this plate, and this plate is not here in any way to better the steering geometry on the already troubled CC01. This is only here to move the servo out of the way of the interior and nothing more. It seems to work very well, as it does clear the hood and allows the driver's side footwell to sit in this area without any interference. There is a FlySky FSGR3E receiver, which I probably own 40 of. It's a fantastic little unit. We have a Y splitter. You can see here we have some extra wires coming off for the lighting kit on the body. The speed control is a Tamiya TEU101BK, which is a, it's an adequate, we'll call it an adequate speed control. And the motor is a 35-turn atomic motor. This will be replaced with a 65-turn motor coming very, very soon. And the servo is a high-tech dual ball bearing metal gear servo. It's an HS 615MG servo with a little metal servo horn, as well as a GPM ball bearing steering link to help the steering just a bit. I know there's additional work that can be done elsewhere, but I've never driven this car and I'd like to see how it goes before I start to modify things. You can see the rear body mount that I created, and when I have the body completed in the next video, we'll talk about how this works. This will allow you adjustment along the axis of the vehicle. And the front body mount has the same operation. It can be slid forward or backward to dial in the body's placement. I did have to put the power switch here on the outside, as it simply wouldn't fit in its correct location. It's double stuck tape in here, and the switch for some reason is broken on the outside, so I'll have to remedy that at some point and make a better mount. But that is where I'm going to leave you in this video. The next time you see this car, the body will be complete and detailed, and then we can finally take this little guy for a spin. Thank you all so much for watching, and we'll see you very soon.